Welcome back to class once again. Welcome back to class, my fellow students. You're welcome back to O3 School app. All right, you're welcome back. All right, today again we'll be talking about a particular topic in physics. But before that, remember the O3 School app has the JAMB app and the WAEC app. Please do well to install the app and also activate so that you have numerous questions for your forthcoming exam to attempt or to play with. All right, so today we'll be talking about gas law. Gas law. I know you must have done gas law in your chemistry, so you also have it in physics, gas law. Remember that air is a form of gas or is a mixture of gas that fill empty spaces. All right. So there are laws that we'll put into consideration while talking about the gases. All right. The first law we are going to see is pressure law. Pressure law, then the Boyles law, then the Charles law. All right. Pressure law, the Boyles law, and the Charles law. And definitely we can also still talk about, okay, the pressure law is also called the Boyles law. Then we also have the ID gas law. Then we also have the general gas law. All right. Now, before we talk more on the gas law, there's what we call molecular movement of gases. And that was stated by some law called the kinetic theory of gases. All right. What happened is that the gas molecules, they move in a disorderly manner. That means they move randomly. All right. When there is presence of temperature, what happens is that these gas molecules, they exhibit what we call the kinetic energy. As a result of the fact, there is more velocity for these molecules to move, to vibrate and translate. All right. Remember that one property of gas is that they don't have shape, rather they fill or occupy they take the shape of the vessel in which they are being contained. So as a result of high temperature, the molecules of these gases, what happens is that they move in a disorderly manner. That is a kind of random motion, zigzag motions. Okay. Now we are talking about gas law. Let's talk about maybe the Boyles law. The reason is that most of these laws have medical applications and even industrial application. In terms of the industrial application, you talk about maybe the combustion engines. Okay. So now let's talk about the Boyles law. The Boyles law. Now the Boyles law states that, all right, if we have a given phase mass of gas, all right, that the volume of a given mass of gas is inversely proportional to its pressure. All right. So the volume is inversely proportional to its pressure. What does that mean? That means that I have my volume is equals to Kp because it is inversely. All right. It is inversely proportional. From mathematics, when volume is inversely proportional to its pressure, so definitely we have K equals to Vp. All right. So we can say PV rather. So we have P1 V1 equals to P2 V2. All right. So we can decide to say, okay, V1 over V2 equals to P2 over what? P1. So this is called the Boyles law. All right. So the Boyles law tells us that the volume of a phase mass of gas is inversely proportional. It's inversely proportional to its pressure. All right. Now, so what that means is that if we have increase increase in pressure will lead to, increase in volume will lead to decrease in pressure. All right? Increase in pressure will lead to what? Increase. If there's increase in pressure, there will be a decrease in volume because they are inversely proportional. All right? So we can also show some diagram. We can represent it with diagram. All right? So I can decide to have something of this nature. All right? Something like this. This is my pressure. Is inversely to volume. Or you can decide to say volume is inversely to what? To pressure. Or we can also have it in this form, in a parabolic form. We have volume, we have pressure. All right? So it means that increase in volume, we decrease pressure. All right? Then increase, if we have increase in pressure, we have a decrease in what? In volume. So what Boyle's law was trying to tell us is that the volume of a phase mass of gas is inversely proportional. All right? The volume is inversely proportional to its pressure, provided that the temperature is kept constant. So if the temperature is kept constant, the volume is what? The volume is inversely proportional to its pressure. All right? So V is equals to K over P. So that's Vp is equals to K. So this is also Boyle's law. So if we have a starting point and ending point, that implies that our K will be V1, P1 equals to V2, P2. Or our K is P1, V1 equals to P2, V2. All right? Now, remember that the Boyle's law has practical applications. For example, we have the scuba diving. Scuba diving. All right? Most swimmers, they use what we call the scuba. What happens is that when the swimmers submerge inside the water, what happens is that if there is increase in pressure, there will be a decrease in volume. There will be a decrease in volume. Or if there's increase in volume, there will be a decrease in what? In pressure. We can also see that in human breathing. Human breathing. All right? Remember, we can, the movements of there's a contraction of the what? Of the diaphragm as we take in air. All right? The taking in of air and the taking out of air is as a result of this principle. All right? Because there's a contraction in the human diaphragm. Then we can also talk about inflating of tires. Inflating of air on tires. All right? A moving tire. What happens is that when there is decrease in pressure of air, that will result to what? The inflammation of the tire. Because what happens is that the volume increases as a result of decrease in what? In pressure. Then filling of balloons also. Filling of balloons. Then we also have syringe. The syringe. The medical syringe. What happens is that when there is when you pulling off the plunger, that's what we call the plunger. All right? The plunger of the syringe, the metallic part in that syringe. Immediately you pulling back. Pulling back means you are reducing the pressure. When you reduce the pressure, there will be more volume of blood or fluid. All right? There will be more volume of fluid or air that will enter into the what? The syringe, passing through the what? The plunger. All right. Then we also have, so remember that the gas law describes the relationship between pressure, volume, and temperature. Even the numbers of moles of this of these gases. So the kinetic theory of gases explains the behavior of gases on the motion of their tiny particles. As I earlier said, what happens is that the molecules of this gas, when they are subjected to a very high temperature, all right, they will gain high kinetic energy, thereby they will be hitting the walls of the what? Of the container. So applications of the gas law can be seen in the scuba diving, the human breathing, inflating of air in vehicle tires, or medical applications, the use of the syringe. All right, from what we have seen, most of the JAMB question you'll be saying that it shows the relationship between volume and pressure. So know that constant temperature, all right, there is a relationship between the volume and pressure. At constant temperature, increase in volume, all right, will lead to a decrease in pressure. At constant temperature, decrease in volume will lead to what? Increase in what? In pressure. All right. We also have what we call the Charles law. We also have the Charles law. So for the Charles law, now Charles law also tells us that what happens is that at constant pressure, the volume of a fixed mass of gas is directly proportional to its temperature. All right? At constant pressure, all right, the volume of a fixed mass of gas is directly proportional to its absolute temperature. All right? So that means at constant pressure, the volume of a fixed mass of gas, the volume, you see, there is what the gas law try to describe, all right? It tried to show the relationship between pressure, volume, and temperature. Now, what is pressure, if I may ask? Remember that the pressure is force per unit area, all right? If I have this surface, all right, let's say I have a pressure. Pressure is the force. Pressure is the force over area. So pressure is force over area. Now, the volume is talking about the area times height, all right? An entire surface where that pressure is being exerted is the volume. Now, we talk about temperature. We know that temperature is a property, all right? It's a property that tells us, is a property of matter that tells us about either the hotness or coldness of a system, of a body. And temperature differences result to heat, because heat occur as a result of temperature what? Temperature differences, all right? So what Charles' law is telling us that at constant pressure, that the volume of a fixed mass of gas is directly proportional to its what? To its temperature, all right? So we can say, we can have a linear, because since it's directly proportional, we can say volume has a linear relationship to what? To temperature. So that means volume is directly, this is just a mathematical representation. Volume has a linear relationship to temperature. So volume is directly proportional to temperature, all right? So V equals to K what? KT, all right? So V over T is equals to K, and this is constant, is a constant. So we can say that K, if we have a starting point, all right, and a finishing point, we can decide to say that K is equals to V1 over T1 equals to V2 over what? Over T2. Now, what happened is that, remember that whenever there is heat, all right, when there is increase in temperature, it will lead to a flow of heat. And when there is heat, definitely there will be what? Expansion. And when there is expansion, there will be increase in what? In volume. All right? Because from we have linear expansivity, area expansivity, and volume expansivity. The volume expansivity of a material is the increase in volume of that material per unit volume for every degree rise in what? In temperature. So when there is increase in temperature, that will result to heat flow. And when there is heat flow, it will lead to expansion. And when there is expansion, there will be increase in what? In volume. So increase in heat flow as a result of temperature will also lead to increase in volume. All right? So volume is directly proportional to what? To temperature. So increase in temperature will lead to increase in volume. So that is why volume is directly proportional to what? To temperature. Okay. Now, what are the practical applications? What is the practical application of this gas law? All right, we can see it in hot air balloons. All right. Then we can also talk about the hot air balloon causes there'll be a rising hot air balloon rising as heat causes expansion. And heat causes what? Expansion. Then we have bread rising in the oven. Bread could rise in the oven. Bread rising in the oven. All right. Bread rising in the oven. Then what? That application can be called maybe baking and cooking. Then, okay. Now, what happened is that the yeast for the formation of bread contain carbon 4 oxide. All right. As a result of heat from the oven, what happened is that the carbon 4 oxide as a gas will tend to what? Expand. And when it tends to expand, there will be increment in the bread. All right. There will be a rise. That rise is as a result of what? Volume. Why is there a rise in volume? There's a temperature increase. Why is there temperature increase? Remember that the temperature increase will result to what? Rise in heat. So when there's rise in heat in the oven, the carbon 4 oxide in the yeast will result to what? Expansion. The gas will expand. So that expansion result to the rise in the quantity of what? Of the bread. So we can say that Charles' law is applied in baking and cooking. Now in the hot air balloon, the hot air balloon rises. Hot air balloon rises as a result of heat. All right? Now because of heat, when there is heat, that means there is a rise in temperature. Now because of this rise in temperature, what happened? There will also be what? Volume increase. The volume will increase. All right? The volume will increase. So we can also see more application on the Charles law. All right? Let's assume we have some fluid in this form. All right? Then we have some flame. This is flame coming as a result of maybe heat. All right? Now, what you observe is that here, there is increase in volume. There is increase, all right? There's increase in volume, all right? There's increase in volume as a result of more here there's more heat. And when there is more heat shows that there is high temperature. Higher what? There is a higher temperature. So because of higher temperature, there will be increase in volume here. If you watch this place, the volume reduce. The volume reduce as a result of what? There's a decrease in temperature. All right? There's a decrease in temperature. Now, if we remember from anomalous expansion of water, irregular behavior of water, we said that at 0 to 4 degrees Celsius, we were made to understand that water exhibits some kind of behavior. Water will do what? Contract. All right? Water contract instead of expansion. But from now, when water contract, there's a decrease in volume, but there's increase in density. But above, from 4 degrees Celsius, above 4 degrees Celsius to 100, all right, water expand. And as water expand, there is increase in what? There will be increase in volume. So what do you observe? It means that as the temperature increases, volume increases. So from Charles' law, we need to understand that the volume of a phase mass of gas is directly proportional to the temperature, provided the pressure is kept constant. Okay. All right. So we have some diagrammatical representation. Because of the linear relationship, there's a linear relationship. So we can say that there is a linear relationship. All right. There's a linear relationship. So what happened? There is temperature here. There'll be volume here. All right. As we move here, we have our volume. As we move here, we have our volume. As we move here, all right, we have our volume. All right. So let's say here is 10, 20, 30. I remember that the volume is in centimeter cube. Now let's talk about temperature in Kelvin. All right. If our temperature is in Kelvin, let's assume here is 273, 373, 473. All right. So let's say this is T1, T2, T3. All right. V1, V2, V3. All right. Charles' law. So that implies that we can have temperature and volume relationship. All right. We can have temperature and volume. All right. So that we can say that at 273, the volume was 10. All right. Remember, this is Kelvin and this is centimeter cube. At 373, the volume was what? Was 20. All right. At 473, the volume was what? Was 30. So it shows that increase in temperature will lead to increase in what? In volume. The more the temperature, the more the volume. All right. So that is what Charles' law tried to explain. At constant pressure, the volume is directly proportional to its what? To its temperature. Okay, we also have the pressure law. We also have the pressure law. Now for pressure law, for the pressure law, it says that at constant volume, all right, at constant volume, pressure is directly proportional to what? To temperature. All right. So that means P is equals to KT over T over T. All right. This cancels this. K becomes P over what? T. So we have P1, T1, P2, T2. So this is also the pressure law. That constant volume, at constant volume, the pressure is directly proportional to what? To its temperature, if the volume is kept constant. So we can see such application in most pressure cookers. All right? For pressure cookers, when the pressure increases, temperature will also increase for pressure cookers. All right? Vehicle tire pressure. All right? The vehicle tire pressure. All right? The vehicle tire pressure changes due to heat. Changes due to what? Due to heat. The vehicle tire pressure changes due to it. We can also have air compressed inside a cylinder. All right? The pressure is always directly proportional to temperature at constant volume. So this what pressure law is telling us. So we also have a relationship. We have a relationship. All right? So let's assume this is pressure and this is temperature. All right? All right? So it means that as pressure increases, temperature increases. As pressure increases, temperature increases. Remember, the temperature is in Kelvin, while pressure is in Newton meter square or in Pascal, either in Pascal or in bar. Now, gas law is also applicable in aerospace engineering. All right, if you study thermodynamics, because what is thermodynamics? Thermodynamics tells us about heat flow in a material system. All right, thermodynamics is an axiomatic science. It's a science that you can't argue. It's an axiomatic science that deals with heat transfer and energy conversion in a material system. So energy conversions, heat flow. All right, so pressure law is also applicable because it's applicable in pressure cooker. Pressure cooker is a thermodynamic system. Vehicle tire pressure changes due to heat. It's also the vehicle is a thermodynamic system because there's energy conversion and there is heat flow. All right. So think of any engineering equipment, any engineering materials, any what do you call it? Any traction systems. You talk about the vehicles, the aerospace, they are all thermodynamic systems because there is what? Heat transfer and there's energy conversion in such a system. Okay, so let's see some related questions from the O3 School app. You remember the O3 School app has the JAMB app and also the WAEC app. So let's see some problems relating to what we have been saying so far. All right. So let's see. Okay. Before that, we also have what we call. Okay. Before that, let's take some. I didn't deliberate on the general gas law. All right. Now, for the general gas law, there's what we call the general gas law. The general gas law. All right. The general gas law shows the relationship between pressure, volume, and temperature. All right. So we have P1, V1, T1, P2, V2 over T2. All right. Where P1 is the initial pressure. All right. V1 is the initial volume, and T1 is the initial temperature. All right. Then P2 is the final pressure. Then V2 is the final volume, and T2 is the final temperature. So this relates the general gas law. Then we also have the ID gas law, the ID gas equation rather. All right, here we have the gas constant and the numbers of moles. And that one says that PV is equals to nRT. All right, P is pressure, V is volume, then N is the amount of substance, amount of substance in moles. All right, and R is gas constant, which will be given 0.82 something. Then T is temperature. All right. So this is an ideal gas equation relating pressure volume. That pressure volume is directly proportional to the numbers of moles, also to the gas constant, and to the temperature. Okay, so let's take some problems from the O3 school app relating what we have been saying so far. If you have not installed the app on your phone, please do well to install, and definitely do well to do what? Activate. Now, when you activate, it will give you license to all the benefits you have in that app based on several subjects. Your physics, your chemistry, your English, they are all there for you to practice in preparation for your WAEC and JAMB. All right? Okay, so let's see. We have a question. Okay. We have a question from JAMB 2009, question 20. All right. He said the pressure of 2 moles of an ideal gas, 2 moles. That means N is 2 moles of an ideal gas at a temperature of 27 degrees Celsius, and volume is 10 raised power minus 2 meter cube is dash. So we have a gas constant of 8.313. All right, joules per mole. All right, so he said the pressure. What we need now is the pressure. This is joules. All right, first, this temperature is in degrees Celsius, so we need to convert it to what? To Kelvin. In doing that, T becomes 27 plus 273. All right, so definitely that should be 300 degrees Celsius. All right, so that's 300 degrees Celsius. Now we know our relationship that PV is equals to N RT. All right, over V, because the question demands for the pressure. So this will go. So P, what is N? 2. What is R? 8.313 times 300 over the volume. Volume is 0.01. All right? 0.01, because you have 10 raised power minus 2. That's 0.01 meter cube. All right? So let's use our calc. We have 2 times 8.313 times 300 divided by 0.01. Okay. So we have pressure. The pressure is 498780. So we can move 1, 2, 3, 4, 5. So that's about 4.9. 4.9. If we approximate this, 4.99 times 10 raised to power 5 Newton per meter what? Per meter square. All right. So the correct answer there is A. The correct answer there is what? Is A. So you follow this principle. All right. This is an ideal gas. For an ideal gas, I said it before that PV is equals to NR. PV is equals to nRT. All right. So we are looking for pressure. All other parameters are given. So you substitute. So we have P equals to nRT over V. All right. If you plug in the values, we have what? 4.99 times 10 raised to power 5. That is JAMB 2009, question 20. All right. Okay. We also have a question from the JAMB app. We also have a question from the JAMB app. We have 1989. 1989. So let's see what it's all about. All right. So JAMB 1989, question 8. It says that the pressure on the gas of constant gas thermometer. So we have a constant gas thermometer. All right. Of the ice point is given and the steam point is given. We have various classification of thermometer. We have the liquid in glass. We have the gas constant volume. All right. We have the thermocouple. Which other one again? We have the resistance thermometer. All right. I explained in the previous video. For resistance thermometer, the thermometric substance used might be platinum wire. All right. Because of the resistance of that platinum wire. A little change in resistance will give rise to change in temperature. And a little change in temperature will give rise to what? Change in resistance. So that is why most of that, the resistance thermometer is a very good sensor, all right, in engineering. Now, we also have the liquid in glass. The liquid in glass are mostly used maybe for clinical thermometer, contain the mercury, all right? For a very high temperature region, mercury is mostly used because it can measure a very high temperature, all right? The thermometric substance in the clinical thermometer is what? Is mercury. Then in a very cold region, they make use of the alcohol in glass because alcohol has a very high freezing point, all right? Because of that high freezing point, and another use is that it can measure a very low temperature, all right? A very low temperature, you can use the what? The alcohol. So most of the thermometric substance we have is the platinum wire, the mercury, and the alcohol. They are mostly called the thermometric substance, and they have practical applications because of the change in their physical property as a result of change in what? In temperature. All right? So let's see 1989, question 8. It said the pressure on the gas constant. So let's take our fundamental interval because here for the fundamental interval, we have the steam point. All right? We have the steam point and the unknown point. So this is the unknown region. All right? Then we have the ice point. All right? And we have the steam point. Remember in our previous video when we were talking about temperature measurement, the steam point is called the upper phase point. All right? And you have it as at 100 degrees Celsius for Celsius scale. For Fahrenheit scale is 212. Then for the ice point, we have the 0 degree what? Celsius. All right? Liquid above 4 degrees Celsius to 100 will expand under heating. All right? And what happened? There will be increase in volume. And below 0 degrees Celsius, what happened? The volume will also increases. All right? Volume will increase. Density will decrease, as stated from anomalous expansion. So let's go back to this question. He said the pressure of this gas, increase the light, the pressure on the gas of constant gas thermometer, all right, at the ice point is 325, all right? So there's a relationship. Let me bring this here, 1989, question 8. So there is a relationship. There's a relationship with length. So we call it temperature-length relationship. So at steam point, it was 325 millimeters. All right? Then he said at the ice point, it was 875 millimeters. All right? Now, find the temperature. So there's an unknown temperature here when the length measures 190 millimeters. So what we do, there will be a kind of direct proportion. All right? Now, what is this direct proportion? So what do we do? There will be a direct proportion. Direct proportion in the sense that as we move lower, considering what I'm saying, as we move lower, all right, there might be increase in temperature resulting to maybe decrease in length. All right? Or maybe increase in temperature might lead to increase in length. So from the direct proportion, we'll know. So we have theta minus 0. All right? 100 minus 0. Then we have 190 minus 875 over 325 minus 875. So this is called the direct proportion. That's what you do. Theta minus 0, 100 minus 0, 190 minus this, 325 minus this. So that is the direct proportion. It shows the relationship. All right, so let's see. Automatically, this will give us theta over 100. Then we have 190 minus 875. So that gives us minus 685. All right. Then 325 minus 875 again. We have 5 minus 50. All right. So minus can cancel minus. 0 here can cancel this 0. All right. So let's create a space. This can go. So if we do that, we have theta over 10 equals to 685 over 55. So 55 theta is equals to 685, 0. If we multiply this to this. All right, so theta is 685, 0 over 55. All right. So what do we have? 6850 divided by 55. So that's about 124 degrees Celsius. So we have 124 degrees Celsius. All right. Now, if you check your options, if you check the options, they are all in degree Kelvin. And this guy is in what? Degrees Celsius. So what do we do? Okay. The steam point was lowest. So let's see. Minus 273, 148. Okay, there's a, we take the lowest point. The lowest point, sorry. It ought to be like this. It's supposed to be 190 minus 325, then 875 minus 325. All right, so that's what we are supposed to get because this value is greater than this. So we have 190 minus 325. So we have minus 135. All right. 875 minus 325. We have, okay, this one still remain. All right. So our 0 can cancel 0 here. So what do we have left? What do we have? So we have theta over 10 equals to minus 135 over 55. Because if 0, cancel this. All right? So we have 55 theta is minus 135, 0. All right? Then theta becomes, so 1350 divided by 55. So we have minus 24 degrees Celsius. So that means that at minus 24 degrees Celsius, we have a 190. We have 190. Okay, so remember that temperature in Kelvin is theta degrees Celsius plus 273. All right? So minus 24 plus 273. That will give us a positive answer. So we have 249 K. 249 K. So the correct answer there is B. They had 248. So we can go with what? 249. That is JAMB 1989, question 8. Question 8. All right. So let's move ahead. Okay, we also have 1989, JAMB 1989, question 9. A column of air has a length of 10 centimeters. Is strapped in a tube at 27 degrees Celsius. So temperature is 27 degrees Celsius. What is the length of the volume at 100 degrees Celsius? So at 100 what? Degree Celsius. So that means that if we watch this problem, it shows that the pressure is kept constant. So because the pressure is kept constant, that means the volume is directly proportional to each temperature. And that is Charles' law. But if we watch, we know that volume is area times length. All right? Volume is area times length. So keeping the area constant, if the area is kept constant, all right? So that means volume is directly proportional to length. So we know that volume also is directly proportional to temperature. So that means length is directly proportional to temperature. So we can say the length is directly proportional to temperature. So that means the more the length, the more the temperature. The more the temperature, the more the length. All right? So that implies that L is equals to KT. All right? So L over T is equals to K. Here we can have L1, T1, L2, T2. So L1 over T1 equals to L2 over T2. All right? Now, mind you, this temperature, they are in degrees Celsius. So we must convert them to Kelvin. All right? So that means at 10 centimeter, T1 was 27 plus 273. Then we're looking for L2 when the temperature increases to 100. So we have 100 plus 273. All right? So definitely this is 10 over 27 degrees Celsius plus this will give us 300. L2 over 373. 100 plus this 373. All right? So one of these 0 can cancel this. So which implies that 30 times L2, 30 L2 equals to what? 373 over 30 over 30. So that means L2, 30 we cancel 30. So what do we have? Okay, so we have 373 divided by 30. So we have 12.8 433 centimeter. So the correct answer there is A, 12.4. So this shows that when the area is kept, the volume is area times length. All right? But when the area becomes constant, the volume will be directly proportional to the length. All right? So the more the volume, the more the length. Now, coming to Charles' law, the volume is directly proportional to length also. The volume is directly proportional to the temperature. So in the place of volume, we replace with length. So that means length is directly proportional to what? To temperature. So you must know some formulas and parameters analysis. That volume is area times length. You must put that into consideration. If not, you won't be able to solve this problem. You might just think, oh, the question, there is no volume. How do we relate volume to pressure? How do we relate volume to temperature? From our knowledge of volume, is three-dimensional shape. Volume is area times length. So here, area is not, they didn't specify on area. They specify on length. So there is a linear relationship between volume and length, keeping area constant. All right? So if the area is kept constant, it means volume is equals to length. And now volume is directly proportional to temperature. So the more the volume, the more the temperature. All right? So now, if volume is directly proportional to length, where we have volume, we replace it with length. Why I'm trying to explain this is that most students will say, oh, we've done Boyle's law, we've done Charles' law, they didn't talk about length. How come they are not relating length and temperature? All right? The reason is that volume is equals to area times length. So keeping area constant, the volume will be equals to length. So from your Charles' law, in the place of volume, you represent it with what? With length. All right? So here now, the length is directly proportional to what? Temperature. So the correct option there is A, and it's 12.433. So let's move ahead. Okay, we have another question. This is on general gas law. I gave you a formula on the general gas law. We have the P1, the V1 over T1 equals to P2 V2 over T2. So that is 1989, question 10. Question 10. Okay, question 10. The question says that a mass of gas at 7 degrees Celsius, all right, we have a mass of gas. That means that T1, all right, is 7 degrees Celsius. And 70 centimeter millimeter, 7 centimeter mercury. So that means P1 is 70 centimeter mercury. All right? Remember that your atmospheric pressure has a constant value. So this value now is below the atmospheric pressure. The atmospheric pressure is 76 centimeter mercury. Or in millimeter, that would be 760 millimeter mercury. All right? So we have 70 centimeter mercury. Then, of mercury has a volume of, so there's a volume, which is V1, is 1200 centimeter cube. Now, they say determine its volume. Determine its volume. That means, so we can call this one the starting or the initial values, all right? The initial conditions or initial values. These are the initial values, all right, before the change of state. Now, I say determine the volume at, so we have is final values now, all right? So when T now, T2 is 27 degrees Celsius. Without being told, 27 degrees Celsius is directly 300 Kelvin. All right? So that means 27 plus 273. Somebody may ask, why are we adding with 273? if you watch the previous video, all right, we talk about the fundamental intervals. Now, the fundamental interval is the difference between the steam point and the ice point, all right? Every scale has their fundamental intervals, all right? So for the Kelvin scale, the upper fixed point is called the steam point, and it's 373, all right? Then the lower fixed point is at 100. So that's why there is a subtraction. So from that subtraction, we're able to get that fundamental interval. So that shows the relationship. Unlike the Fahrenheit scale, you have 212 and 32. The fundamental interval becomes 180. So 212 minus 32, you have 180. All right? So let's see more information that is given. Where P2 is 75 centimeter mercury. So pressure can be measured in centimeter mercury, millimeter mercury, sometimes in Newton per meter square, sometimes in bar, sometimes in Pascal, depending on the one that is given to you. So for this is centimeter what? Mercury. So we have to find V2 is unknown. So V2 is unknown. Okay? So let's solve. Now for a temperature of 27 degrees Celsius, that will be 27 plus 273. That's approximately what? 300 Kelvin. All right? Then this one becomes 280 Kelvin. We add 7 plus 273. That's the standard what? The standard value as stated by Charles' law. All right? So now for V2, let's see our relationship. P1 V1, T1, P2 V2, T2. This is the general gas equation, all right? So we need V2. Here, mathematics come. You must play with your mathematics. So we have P1, V1, T2, all right? Over P2, T1 equals to what? V2. So this is the formula we are going to apply. Now we need V2, all right? So V2 becomes, what is P1? 17. What is V1? 1200. What is T2? T2 is 300. Over what is P2? P2 is 75. T1, 280. Okay? So we try to amass. We have 70 times 1200 times 300. Okay, divide by 75, divide by 280. Okay, so we have 1,200 centimeter cube. So the correct answer is A. All right? The correct answer there is what? Is A. Okay. We have another question from 2024, question 2. So for question 2, see, 2024, question 2. It said, if the volume of an ideal gas, a perfect gas, an ideal gas, is half, while its temperature is doubled, the pressure will be what? So let's see. The volume. So let's say we have V1, P1, T1 of an ideal gas. All right? Now they said, now let's say V1 is equals to V. For an ideal gas, your V1 is equals to V2. All right? Your P1 is equals to P2. Your T1 equals to what? Is equals to T2. All right? So we can say that V1 is equals to V2 is equals to V. That's what it means. And P1 equals to P2 equals to P. That's for an ideal gas. But the information says that if the volume of an ideal gas is half, So that means that if it's half, so we can say that V1 equals to V. So they said if is half, so we can say that then V2 is 1 over 2 V, because P1 is equals to P and T1 is also equals to T. So we can say that V2 is equals to 1 over 2 V, because the question says is halved. So let's see the other information. It said why the temperature is doubled. So that means T2 is what? Is doubled. So T2 will be what? 2T is what? Is doubled. Then they said P2 will be what? So P2, we don't know. All right? V2 is half of V1 because V1 is also V. T2 is equals to 2T because it's doubled. Another year, it may not be double. They will tell you maybe it's 4 times. All right? So we can employ the general gas equation, because the general gas equation shows relationship between volume, temperature, and what? And pressure. All right? So we can say that P1, V1, T1, P2, V2, T2. All right? So let's plug in our value. We don't know P2, all right? So we can say that P2, from what I'm seeing here, P2 is P1, V1, T2. That's change of subject formula. You have to be good. Your mathematics, you have to be fast. So P1, V1, T2. What will be left? We have T1 and V2. All right, so let's plug in our values. So P1 will remain. What is V1? We have V1. V1 is P1 is same thing as P, and V1 is also same thing as V. So we have, but T2 is 2T. All right? Over V2. V2 is 1 over 2V. 1 over 2V. Right? Times then T1. T1 is equals to T. All right? So what happened? V can cancel V. T will cancel T. So P2 is equals to what? P times 2 over 1 over 2. From the law of indices, if I have 1 over 2, 2 goes up. All right? I'll have P times 4. So we have what? 4P. So P2 is equals to 4P. So let's see the options. Now, if the volume of an ideal gas is half, while its temperature is doubled, the pressure will be dash. A, decreased by a factor of 2. B, increased by a factor of 2. C, decreased by a factor of 4. And D, increased by a factor of 4. So from what we have seen, it's increased by a factor of what? 4. So the correct answer there is D. Okay. Let's see another question. 1994, question 15. 1994. So 1994, question 15. Now, a motor tire is inflated to pressure of, so that means the initial condition, P1 there is 2 times 10 raised per minus 5 Newton per meter square. When the temperature of air is 27 degrees Celsius, all right? So that means T1 is 27 degrees Celsius. Now, what would be the pressure in it at T2, 87 degrees Celsius? What would be the pressure? What is this relationship? So that means there is a pressure-temperature relationship. So what happened in that case? It means that the volume is kept constant. The volume is kept constant. So when volume is kept constant, automatically we know that is pressure law. All right? So for pressure law, we know that P1 over T1 is equals to what? P2 over T2. Now, this temperature, they are all in degrees Celsius. So we need them in Kelvin, all right? So I can come over here that T1 is 27 degrees Celsius plus 273. And that is 300 Kelvin, all right? Then T2 is 87 degrees Celsius plus 273. So if we plug in that 87, 273, so that's about 360 Kelvin, all right? So now we need P2. What happened is that the pressure and temperature relationship, as I've earlier said, they are directly proportional, all right? The more the pressure, the more the temperature. Look at it. At 27 degrees Celsius, it was 2 times 10 raised to power 5. So at 87 degrees Celsius, we need a value that will be more than 2 times 10 raised to power 5. So let's compute. Now, if you do that, P1 is 2 times 10 raised to power 5. T1 is 300. P2 unknown. T2 is 360. All right? 0 can cancel 0. Then we can equally say 5 here or 6 here. 6 here is 5. 6 here is 6. All right? So 2 times 10 raised to power 5 over 5 equals to P2 over 6. So definitely we can change something here. That 2 times 6 is 12. So 12 times 10 raised to power 5 over 5 is equals to what? P2. All right? So that implies that P2 is equals to, so 12 divided by 5, that is 2.4. So 2.4 times 10 raised to power 5 Newton per meter square. All right? So pressure law has been proved. Increase in pressure will result to increase in temperature. At 27 degrees Celsius, it was 2 times 10 raised to power. Let's even forget about the 10 raised to power 5. At 27 degrees Celsius, it was 2. At 87, it was 2.4. So there was an increment of what? 0.4. All right? So that is that on 1994, question 15. Okay. Thank you. That will be all for this class. See you in subsequent video. Thank you.